Pythagorean theorem. To find missing side lengths of a right triangle, use Pythagorean theorem. That's for any other right triangle, except for our special right. Can you get off your phone?
Well, I wasn't.
It wasn't in your hand? Okay.
Okay.
Alright, so what we're going to do first is we're going to talk about facts of a square, because you make a 45, 45, 90 from a square. What do we know about squares? All sides are congruent. Alright. 4 right angles. And you get points for that. 2 points. Does anybody know anything about the diagonals or remember anything about the diagonal? Do what? They bisect the angle. Yes, diagonals bisect the angles. And what does the word bisect mean? Cut in half. So what is half of 90?
45.
And that's where we get a 45, 45, 90 from. So what I want you to do is I want you to stop talking while I'm teaching, and I shouldn't have to tell you that every single day. Every single day. And put a box in every single corner. And then I want you to label it X, Y, Z, Q. Okay, so now what I want us to draw is a diagonal from Y to Q. Now what we're going to do is we're going to find the length of the diagonal, and we're going to see if it's going to be the same thing every single time we work out a problem. Now, what is the measure of this angle right here?
45.
Y. Yes. Good. Y'all get a point. Alright, what is the measure of this angle right here? 45. And that's what makes it a 45, 45, 90 triangle. Now, if you can't see that, I'm going to cover this up. Ta-da! It's a 45, 45, 90 triangle. If these two angles are congruent, that means our sides are what? Congruent. Take a point, Eric. And we're going to let this side length be 1 centimeter. So if this is 1 centimeter, what's this side? Hot dog, hot dog. Now, it is a right triangle. So what method would we use to find the missing side length? Pythagorean theorem. And what is Pythagorean theorem?
A squared plus B squared equals C squared.
Okay. Now, do we know our C, or is that what we're trying to find?
We're looking for the C.
We're looking for the C. Good. We're looking for our hypotenuse. What is A?
A is 1 centimeter.
As a leg.
Oh, snap.
And what is B?
Oh,
1.
my bad.
The length.
1.
Does everybody see where we got these numbers from before we go any further?
1 centimeter.
Because we got it from there. All right, and what is 1 squared?
1.
1 squared is?
1.
And what is 1 plus 2? 1 plus 1?
2.
And what do I do from here?
You square root.
I do take the square root. Now, when you're doing 45, 45, 90, you have to leave it in simplest radical form. Do not take the square root of 2. Is there any perfect square that goes into 2?
Yes. No.
2 is not a perfect square.
Oh.
So anything other than 1? Nope. So we leave it as C equals the square root of 2.
So it's just square root of 2.
That's it. So now what we're going to do, so I'm going to give you another triangle. And we're going to see if a pattern forms. So this is 45, 45, and 90. And I'm going to let this be 5 inches. If this is 5 inches, what is this side length? And we're going to call this x. Use Pythagorean theorem and find x without me. Do not get a decimal. Simplest radical form. You're not done yet, heifer.
Oh, so we're not even going to like...
You're going to go into the square root. But don't get a decimal. So what did you plug in?
5.
You haven't plugged in anything yet, have you?
Well, I think you accidentally write it in marking on it. So I thought it was 5 squared
Okay.
plus 5 squared equals 6.
Okay. Do you want me to put my card on the board?
Yes, please. Oh, you can't do 10, I'm dumb.
You have to use the pink column.
You can do 25.
Ham sandwich.
Take a point.
Work it out. But yes, you do get a point.
Oh.
You said don't.
Right. We're not taking the square root, finding the simplest radical form.
Forget about it.
It is too late for your grade. How about that?
Oh, you ain't got to do this like that.
I still got to put it in that.
Do I need to leave my card up there? Can I turn it sideways over here? How about like that? Because I'm just tired of sitting here holding it. Did everybody get to this point?
Yes.
Awesome. Did we get beyond this point, or do we need a mo?
We can go.
That's just 50, right?
Does anybody still need a minute?
It's just a square root of 50.
Why would what?
I just got 7.
Are we always going to leave it?
It's simplest. I'm not done.
Okay, so then 25?
Yeah. So you break 50 down into 25 and 2.
Oh.
You didn't actually ever finish a sentence, baby. I understand, but I can't read your mind. I don't know what you're trying to say.
5 and then the square root.
Yes, and you get 5 root 2. Take a point.
Oh.
And where did that 5 come from?
25.
Hot dog, hot dog. All right, now this had square root of 2 and this had square root of 2. We're going to do one more, and we're going to see if it's a pattern. Una más. All right, this is going to be 3. This is going to be 3. Work it out. Chop, chop. Super excited. I love special right triangles. Love it.
Okay, so that's what I did.
Is that what this is?
Yeah.
I thought you was supposed to just leave this 50 since nothing goes to 50. That's easy.
25 does go into 50.
Someone already left the tag.
Because half of 50 is 25 and 25 times 2.
Okay, 50 divided by 25 is 2, right? So that's where I got 25 and 2 from. What's the square root of 25?
5.
That's why I brought 5 to the outside.
What about if you put it up as like 2 times 25?
Oh, okay.
Instead of 25 times
But then you'll still get 5 root 2.
5 or 2.
Hold the phone.
Hold on.
What?
45 matter.
Yes.
At some point, like if we're missing a side.
Yes.
Oh.
And we're going to talk about that. It's super exciting. Super, super, super exciting. Alright, did you guys do 3 squared plus 3 squared equals c squared? And then you got 9 plus 9 equals c squared? And then you got 18 equals c squared? And then you took the square root? And it's 9 and 2, so what's the square root of 9? And you're left with 2. Now, what are we going to have in our answer every single time? A root 2. It's going to be part of your problem every single time. Every single time. Take a point. Now, what we're going to talk about, our side lengths are always the same. And this is always, now, this was 1 times the square root of 2. What was this one?
5.
5 root 2. And where did we see a 5 at?
5 right there.
Alright, and this was what? 3 root 2. And where did we see a 3? So it's always your side length times the square root of 2.
Boy, we got 2 different side lengths.
Then it's not a 45, 45, 90. So the reason you have the same side lengths is because these two angles are congruent. And if your angles are congruent, that means your sides are congruent. That's what happened when we split that square in half. If it's not, use the Pythagorean theorem.
That's how we're
Yep, that's how we'll know the difference. We're going to learn about 30, 60, 90 tomorrow, but we're going to talk about what happens with that one. It's fun. All right, go to the next page with a chart. Yeah. And it's a lot of fun once you figure out the pattern.
I didn't ever like the chart stuff.
We haven't even filled in the chart. Okay. All right, so if I give you the side lengths are 2 and 2, that means that our hypotenuse is going to be what? 2 root 2. Who said it? Take a point. Because if it's x and x, if these two are the same, that means it's going to be x root 2 or 2 root 2. So if it's 4, if I have 4 and 4, what's my hypotenuse going to be? 4 root 2.
Oh yeah, because half of 4 is 2.
That has nothing to do with it. But yes, half of 4 is 2. Now, the pattern is x, x, x root 2. So every single time, it's going to be your side length times the square root of 2, which is what I just said and Star just said a minute ago. But we weren't listening. So if it's 2 and 2, your hypotenuse is going to be 2 root 2. If it's 4 and 4, your hypotenuse is going to be 4 root 2. Yes. I can't. We're in the middle of a lesson. If you put the triangle together, you need to be able to tape it. We're in the middle of a lesson. All right. 6 and 6. What would it be? 6 root 2 is how we say it. 6 root 2 is how we say it.
You just keep going to 2 in every one.
There's going to be a root 2 in every one, which is what I said a minute ago. But again, the whole listening thing is very difficult for us.
I wanted
So that you get addicted to it and it's a racket. Yes, I did know that.
I just put root 2 all down my face.
Oh, don't do that. Because what if I give you... What if I told you that it was 8 root 2? If I'm not done talking. If I told you that the hypotenuse was 8 root 2. How? Why?
Because that's
X equals X root 2.
Yes. Alright, and then, let's go crazy. What if I gave you root 6?
it'd be 6, 6.
No.
No, 2, 2.
What's different about this one?
3 root 2.
Why?
No, that's not 3.
It's root 6, right?
So it'll be 6.
I'm not, just let me talk. Just. Now, what does this have?
2.
Okay? What? You do 6 divided by 2, which is The reason is, and I'm going to write this out to the side. Now, I do love our enthusiasm and that we're trying to figure it out, but just give me a mo. Root 3 times root 2. If they are both under the radical, you can multiply them together. And what is 3 times 2?
6.
Which is root 6.
Oh.
Let's do it.
Magic. All right, so what if it was root 10?
It'd be 5 and 2. 5 and 2.
Because 5.
So I would write the number 5.
No, you square root of 5.
So root 5,
Root 2.
root 5. The sides are the same.
Oh, 10 divided by 2. Okay.
Yes, so root 10 divided by root 2 is root 5. Okay, what if I had 5 root 14? Now, what do we know is going to be part of our answer? 5 is going to be part of our answer. Okay, and then what's 14 divided by 2? So it's root 7 and root 7. You ready to try one without me?
Yeah.
What if I give you 3 root...
What? Why are you even me ugly?
10. No, 18.
12.
21. No.
22.
Is something big?
You got to go ahead.
1,846.
38.
Add all those numbers.
You want me to say it?
No, mister. You can in a minute, mister.
Oh, it's hard.
Okay, mister, tell me the answer. 3 root 19. Take a point.
I was going to get so sad.
Why?
Because I thought I had it right. And then.
Not you. Him.
Sorry.
What, darling?
Can I tell you how I found it?
Yes, tell me how you found it.
First, I remember what you said about when
Hey, she's talking. Hush.
above it, you said 5 going to be like on the outside of the root.
Yep.
So I took 3 and put it on the outside, and I divided 38 by 2, and I got 19.
Look at you go. Take a point. Love it. You need to put some lotion on that. Like a something. All right, what if I gave you 14? This is where it gets something. It gets all kinds of fun.
You put the square root on 12?
Nope.
That's bothering me.
We know it's going to be 7 and 7, but what do we have to have in our answer?
A square root of 2?
Oh, it's 7.
The kids said that too. I get 2 points.
Now, do you want me to show you how I got that, or do you see the pattern?
We see the pattern.
Wait, does anybody want me to show you how I got it? Okay. All right, so you know that we divided this one by root 2, correct? So if I do 14 divided by root 2, I cannot divide those two numbers because 14 is not under the radical. And you cannot have a radical in the denominator. So what you do is you multiply the top and bottom times the square root of 2. Now, what is 2 times 2?
4.
And what's the square root of 4?
2.
So you get 14 root 2 divided by 2. What's 14 divided by 2?
7.
So you just cut it in half and slap a square root on it. That's it. So if I gave you 26, 13 root 2.
See, I'm smart like that.
And what if I gave you 48?
24 root 2.
The 2 is always in the house, though.
Yes, the 2 is always in the house. Or a multiple of 2. Like these weren't 2, but they were a multiple of 2, right? And we divided by 2 to get our others. Now what would this be? 24 root 2. How many of us got that right? Take a point.
Okay.
So now what we're going to do is we're actually going to apply it to triangles. And it is super, super, super exciting. So everybody's going to get a foldable, and then we're going to fold it together.
Every time he do like Sean Paul is not being true.
That is a true statement with any part of your life.
Are these like set things we're gonna? They're like all
That's really right. You know, you're sure about that, but you're going to have to do
Are you recording?
That's the bad part about it.
Did she see him?
You know that you can just pay attention and not talk, right? And you have a second period where you can end
I wasn't.
and be a period. What is happening?
I have no period too.
You did not come into your period
You
this
look
morning.
tired.
I know.
Yeah,
I
baby.
have to go to another one.
Hey, you know I come to your house every morning,
You
so.
look like sleep. It's okay.
Okay, so this is how you fold this. Put it on your desk so that it looks like this.
Like these. Like
Alright, and then I want you to fold it like this.
You know I took a whole 3-month folding class and I still
And then I open it back up.
It's an extra Saturday. Oh, wait, there only have two? Yes.
Sebastian was very forceful with that answer. Alright, so I opened it back up. Then I'm going to fold it this way. Ooh, I folded it backwards. That's okay.
Fold it. Put your bag.
I just folded it so that you folded it hamburger style. Guys, all I did was open it like this, and then I folded with my left hand.
I think I folded it wrong.
I did too. It's okay. All right. Now we folded it backwards because this is like the 4th time I folded it today, and I still do it wrong every time. Fold it down, and now it's done. Wait till you see how it opens. It opens like this,
If it had like a sheet for like the head of the business.
and then it opens like this. I know.
Oh my god. Yeah, just that.
It is. And then you just tape down the back. And we're going to put it on 53C. So just tape down example 4. That's the only part you should tape or glue down is example 4. That's right. I'm going to do the same thing.
It's on the back.
Where you open it on the inside.
Okay, I got it.
Yeah, so you only tape down, if you're gluing, you only glue on the part that's, yeah. Alright, so what we're going to do is we're going to write our rules on this side. So it's a special right triangle. If this side length is x, what does that mean that this side length is? And what does that mean our hypotenuse is?
It's centimeter.
90.
What was the question? X. First of all, I had.
So if this is x and this is x root 2. Every single time. Every single time. That's what we just did in our pattern.
I know we was still on that because I was transferred.
No, we're still on the same thing. We're just applying it to actual triangles. Alright, so open. Open one more. We're going to write the same thing in here. If this is x and this is x, what's our hypotenuse?
X root
Root
2.
squared. 2.
Are we ready? Okay. Example 1. If FE is 8, what is ED?
8. Duh.
Okay. And what is DF?
8.
8.
Oh, 8 root 2.
8 root 2. Take a point, Grace.
That's literally all we do.
Yeah.
Okay.
I get it.
14.
Wow. He knows 7 root 2.
All right, now let's look at example 2. This gives us our hypotenuse, and we just did one like that on our chart, where we had, if it's, our hypotenuse is 15 root 2, so if this is 15 root 2, what are our legs going to be?
6.
No, baby. 15 and 15. If this is ham sandwich, guys, if you have to label it. Draw an X and an X and an X root 2.
Oh.
Do that every day. I can't see that. Can y'all see that pink?
Yeah.
Give me 5 root.
Nazero. No, son.
X is in the place of.
What is in the place of X right here?
15.
So what is X going to be?
15.
Ham sandwich.
What you said, man?
Phew. Oh, thank you. That hurt.
Where is it go?
You're still interrupting class. Sit it beside you. All right, let's look. Does everybody see how we got 15 before we go any further? Are we sure?
How do you not know?
All right, example 3. This is X, so this is X root 2, correct? If AB is 7 root 2, what is BC going to be? And then we're going to multiply 7 root 2 times root 2, right? Okay, what's root 2 times root 2? It's root 4, and what's the square root of 4? And what's 7 times 2?
14.
We're a little bit confused right here? Okay, that's okay. So you multiply the 2 and the 2 together because they're both under the radical, right? So this becomes 7 times the square root of 4. But what is the square root of 4? 2, which gives us 14. Do we understand a little better now? Okay. Would it help if we maybe wrote this step each time until we're used to it? Okay. What, darling?
I would be confused at some point because I think since you already have A root 2 on that side, I would think that AC was 7 and CB was 7.
No. Now, the reason you can't think that is because you need to look at where the 90 is. All right? And the 90-degree angle, wherever it's pointing at, that is X root 2. So your side lengths, your legs, are X each time. These are X, and then this is always X root 2. No matter what this says, write down X, X, X root 2. Because those are side lengths. Okay? Alright, let's look at example 4. This is X, and this is X root 2. Now, we just did one like this, right here, where we had 14. And what did we do to get 7 root 2?
It's going to be.
What did we do to the 14 right here?
Divided by
Divided by root
root
2. And then we know that we can't have a radical in the denominator, so we multiplied the top and bottom by root 2, correct? And then root 2 times root 2 gave us 2. Why did this become 2?
To divide.
because it divided out.
Root 2 times root 2 is root 4, and what's the square root of 4? 2. Then how did we get 7?
We
Because we did 14 divided by 2 and then
Okay, so then what could we do here?
Divide that by.
divide 2
divide 22 by
by
2.
root 2.
Divide 22 by root 2. Now, can we have a radical in the denominator? So what are we going to do? You just multiply the top and bottom by root 2. Is everybody with me on how we got right here?
Yeah.
Are we sure?
I think so.
Alright, so we get 22 times the square root of 2 divided by the square root of 4. Where did the 4 come from? Okay, now what's the square root of 4? And what's 22 divided by 2?
11.
No, you could just cut it in half and throw a root 2 on it.
So just do 22 divided by 2.
Yep. Will that help if we write that down?
Yes.
All right. What would help for us to write down right here on example 3?
Not 9 times 2.
Multiply. Take this and times 2. Are we ready to look at example 2, or do we need a mo?
Huh? Oh, no. Yeah.
All right, what did we do on example 2?
We just took off.
We just took off the root.
This is helpful.
I do try to do things that are helpful. All right, so right here, if we get these done, we don't have homework. How does that feel to not have homework?
For the first time ever.
All right, so if UT is root 2, what is FU?
It's something about
All right, and then how would we find FT?
It would be 2 and 2.
just drop the root.
No.
Just drop the root, and what would it be?
2. That's what I meant. Sorry.
Now, for those of us that don't see that pattern as easily, you could also do root 2 times root 2, which is root 4, which is 2. I'm struggling writing today. It's really hot in here now, and I can't focus. Thanks. All right, example 6. All right, so this is x root 2. This is divided by 2 and slap a root on it. Okay, so we're not afraid of that.
Really? I am.
It's a decimal. I would be afraid.
Ta-da! Yeah, that's it.
Yeah, no.
That's 45, 45, 90.
Oh my God, we gotta put it down here. Mars said.
Now what we're going to do is we're going to clean up and make sure our towers, thank you, towers are organized.
Should we glue this down?
Yes.